Hello, my name is Matthew Wadstein, and welcome to the course on Blueprint Communication. We're going to take a look at the common ways to communicate between objects inside of our project. Using Blueprint Communication, we can allow our character to stand on a platform and interact with a door in another room, or alternately, a box can fall down and land on a trigger, allowing access to another locked room. Let's go ahead and take a look at the completed project and what we'll be learning from this course. If you'd like to follow along, you'll have to download the project that comes with this course from the marketplace. And once you open it, you should get something similar to this. This is going to be our starting map. If it doesn't load up to this map, or you need to get back to it, you can find it under the Content, BP Communication, Maps folder under Starting Map. Looking through our project, we can find the BP Communication folder with some blueprints we'll be using during this course, our starting map, and then our player's user interface. All of the assets used to design this course are in the Learning Kit _Games folder. Before we start, looking through our project, we can find the BP Communication folder with some blueprints we'll be using during this course, our starting map, and then our player's user interface. All of the assets used to design this course are in the Learning Kit _Games folder. Before we start, there's something I'd like to note. If you open up a blueprint that only contains data, if it doesn't contain any components or code, you may be presented with this screen. If you do see this and we need to actually work on the blueprint itself, you can click on the Open Full Blueprint Editor button, and then this will open the blueprint into the normal display you might be used to. Something that is important to note is the idea of object hierarchy or inheritance. The fact that the building blocks of our engine are based around objects. Everything we can see inside of our world is going to be based upon an actor, and those actors themselves are objects. This is our parent-child relationship and our hierarchy, and I can demonstrate this. If we go ahead and right-click and choose a new blueprint class, and we go to all classes, we can now actually see our hierarchy. We can see object at the top, and then below this we have our different types. For example, under object, we have actor. Under actor, we have other types of actors. For example, we might have a camera actor. A child of camera actor may be our cine camera actor. And using inheritance, we can go up and down our chain where we can treat one item like another. And that's important to remember as we go along this course. If you're going to follow along, once you have the starting project downloaded and open in the editor, we'll take a look at using the level blueprint for some basic communication between two objects. The first method of blueprint communication we're going to look at will be using the level blueprint. The level blueprint is a blueprint that is part of every level, and it can be used to easily allow communication between objects that exist inside of that level. Let's go ahead and look at the level blueprint. We'll go to the blueprint dropdown on the top toolbar and choose Open Level Blueprint. The level blueprint functions like a normal blueprint level. Let's go ahead and look at the level blueprint. We'll go to the blueprint dropdown on the top toolbar and choose Open Level Blueprint. The level blueprint functions like a normal blueprint, except for a few things. We don't have a viewport because we don't have any components we can attach. This blueprint simply exists for coding purposes inside of this level, and it's unique to this blueprint simply exists coding purposes inside of this level, and it's unique to this level, so we can't easily reuse the code. However, because it exists as part of the level, we can add references, or we can know about items that exist inside of our level at design time really easily. The problem we want to solve here is our cube is going to drop down onto our platform and close our door. Once we push our cube off of the platform, the door will then open for us. We're going to need a trigger volume, so we'll go up to the Create menu, Volumes, and we can drag out a trigger volume.
Character Marzeo. D4, let's go. Probably just lurking. I appreciate the lurk. Thank you. Hope you've been doing well.
And drop it on top of our platform. We can then move it down.
Where's this platform they're talking about? Oh, there it is.
so that way it only triggers when it hits at the bottom part. Now we need for when this trigger volume ends the overlapping. When this cube is pushed off, it opens the door. So how do we do this? With our trigger volume selected in either our outliner or in our world, we can go back to our starting map level blueprint, which we can see here. We can right click on it and we can create a reference to the trigger volume. This will let us talk to the trigger volume. However, we can also add events and call functions on it. So if we go to add event, collision, we have begin and end overlap. We want to choose the end overlap because once we push the box off of this or we end the overlapping, we want the door to open. I'm going to go ahead and zoom in and we see we have a few options. Overlapped actor is the item that is overlapped. So that is our trigger volume. Other actor is the item that is overlapping us, or in this case, ending the overlap. So it'll be our cube. We can drag off of other actor, type in equal, and select that. We have the option to select an asset. So if we choose that and we look through our list, you'll find you can find your blueprints or your items that exist in design time in your content browser, not the actual items in our world. If we go back into our world itself, we can click on our cube, go back into our level blueprint, right click where we want it to be and create a reference. Now this gives us a direct link to that cube, which we can plug into our equals. And now we can compare the other actor to our cube and make sure they're the same. We want to drag off of our equals and do a branch or an if. We're going to hook that up. Now what do we want to do if these two items are the same? Well, we want to open our gate. Well, we need to now talk to our gate. Should be pretty simple. Go back to our map, click on our gate itself. This is our force field. Go back to our starting map, go back to want to open our gate. Well, we need to now talk to our gate. Should be pretty simple. Go back to our map, click on our gate itself. This is our force field. Go back to our starting map, right click, create a reference to it. Now we can talk to that force field and we want to both set it as hidden and disable its collision. So let's do that. Dragging off, we can set the visibility. This is going to set the visibility on the stack mesh component itself. So I'm going to clean this up a little bit and then hook it up to the true. New visibility will be false, so that way it will hide.
Target scene component, okay.
Let's also do the same for the collision. We'll drag off of the component and type set collision. Set collision enabled is what we want. The new type is no collision, so that's correct. We'll wire it up and clean it up a little bit. Now if we were to compile and save and go back to our map, when we play test this, the door should now open when we push our box off. Let's go ahead and push our box off. When we go back, our door is now open and we can walk through it. Now going back into our level, we want to clean this up a little. Let's go ahead and push our box off. Test this. The door should now open when we and save and go back to our map. When we play test.
Curious.
Test this. The door should now open when and save and go back to our map. When we play test this, the door should now open when we push our box off. Let's go ahead and push our box off. When we go back, our door is now open and we can walk through it.
Neat.
Now going back into our level, we want to clean it off and go back, wire it up, enable to component, set the as hit, right click. We want to drag off of our equals and do a branch or an if. We're going to hook that up. Now what do we want to do if these two items are the same? Well, we want to open our gate. Well, we need to now talk to our gate. Should be pretty simple. Go back to our map, click on our gate. Well, we want to do if these two items. Go back to our starting map, right click, create a reference to it. Now we can talk to that force field and we want to both set it as hidden and disable its collision. So let's do that. Dragging off, we can set the visibility. This is going to set the visibility on the stack mesh component itself.
I wonder, maybe. Um, where to go? Just for kicks? Maybe that's the problem. Okay. The bounce bounced it out so it did the end. Okay.
So I'm going to clean this up a little bit and then hook it up to the true. This is what we test this. When we go back, our door is now open and we can walk through it. Now going back into our level, we want to clean this up a little bit so that way we can learn about the level blueprint a little more and give our player going through this little maze a little bit more of an idea of what they're supposed to do. We're going to set the force field's visibility and collision to disabled by default. We can find visible under rendering and disable that. We'll look for collision and we'll change our collision preset to be no collision. Once we've got that done, now it's going to start off with our door open, and we want it when the cube initially drops or starts our overlap, it now closes the door. Go back into our starting map. We have access to start off with our door open, and we want it when the cube initially drops or starts our overlap, it now closes the door. Go back into our starting map. We have access to our cube and our force field, so we're good there. We have our basics of our code here. We're good there. We just need our other event. So we can go back in, click on our trigger volume in the viewport or the outliner. We have our basics of our code here. We're good there. We just need our other event. So we can go back in, click on our trigger volume in the viewport or the outliner. Go back to our level blueprint, right click, add event, collision, begin overlap. We can use the same basic code. So if we want, we can select this code. We can copy it with Control C, and then we can Control V to paste it. Let's go ahead and wire it up. Let's make sure our other actor is wired up properly here. Move this over a little bit. So when the other actor is our cube, when we begin overlapping, we're going to turn on the visibility for our scene component and set our collision to be collision enabled query and physics. Let's go ahead and compile and save this and see what happens when we go to our starting map and hit play. Our force field was hidden and now it is visible again. When we walk up to it, we find we can't do anything with it. We can push our box off. Field was hidden and set our collision a little bit. So when the other actor is wired up properly here, move this over a little bit. So when the other actor is our cube, when we begin overlapping, we're going to turn on the visibility for our scene component and set our collision to be collision enabled query and physics. Let's go ahead and compile and save this and see what happens when we go to our starting map and hit play. Our force field was hidden and now it is visible again. When we walk up to it, we find we can't do anything with it. We can push our box off. Our force field's gone and we can walk through it. While this is nice and this is a good starting point, due to its limitations, we might quickly find we are copying and pasting code multiple times just to do something similar repeatedly. For example, if we have more doors to go through or we have more triggers, our level blueprint might become very convoluted or very bloated. By using blueprints themselves, it allows us to reuse the code easily. So next we'll take a look at communication inside of a blueprint between the components it contains.
Yes, please.
Blueprints are designed to be reused. They'll self-contain where the components and the code are independent, and when we create copies of them, those things are unique. They're composed of components, and due to that, the communication within the blueprints between those components is what we want to look at next. This is the level we're working in. We got our first part done. Our next room, we're going to want a door to walk through and go to our next area. Now we're going to want more doors. So at this point, we should think about reusability. We could recreate the code we did before and paste it into our level blueprint over and over and over, but that's going to become bloated. So let's use a single blueprint and communication within that blueprint to create a reusable door. Now inside of our blueprint communication folder, under blueprints, I've created the basics of our door. If we open up BP_door, go ahead and dock it if you want to, and in our viewport, we can see our door. We can see that we have a trigger, which is a box that we're going to use for the overlap events, and 2 stacked meshes that make up our door. And if we go inside of our event graph, we can find we have no code. So let's go ahead and look at setting up our code. And if we go want to, and in our viewport, we can see. Now inside of our blueprint communication folder, under blueprints, I've created the basics of our door. If we open up BP_door, go ahead and dock it if you want to.
I don't know what that means. I don't want either of these selected. How do I make you not selected? I don't know. Blueprint. Why? Why do I not have this? Okay. Why do I not have blueprint? Event graph. Graph, event graph? Oh, there we go. Hypnota, heyo! When I'm done with this tutorial, I would estimate somewhere called 2 hours. I would guess somewhere around 2 hours. It's definitely not going to be before 2 hours from now. But yeah, it might be a little later if this tutorial runs slow. But yeah, no problem. Hope you're doing well.
And in our viewport, we can see our door. We can see that we have a trigger, which is a box that we're going to use for the overlap events, and 2 stacked meshes that make up our door. And if we go inside of our event graph, we can find we have no code. So let's go ahead and look at setting up our code. One thing that's nice is we've already determined what we need to do, so we can look at our level blueprint and take the code from there. So if we go back to our starting map, if it's not already open, go to your blueprint dropdown, go to open level blueprint, select all the code that I want. I could right click and copy or control C it, and then go back into our blueprint. And I can right click, scroll down, paste here, or control V to paste. We have the basics of our code here. Now we don't need this force field or stack mesh component because we have our door right here. We can drag our door in, drop it, get a reference to it. We can now plug that in to our...
That goes target.
Set collision and visibility. Now we need our events for our trigger. If we go into the trigger itself, and in our details panel, and we scroll to the bottom, we have access to all of our into the set collision and visibility. Now we need our events for our trigger. If we go into the trigger itself, and in our details panel, and we scroll to the bottom, we have access to all of our events. We have our begin and end. So let's create the begin event by clicking the green plus. Let's go back to our... We have our begin and end. So let's...
Oh, begin over. Okay. Hey, give me that back. I need that. End. Okay.
Create the begin event by clicking the green plus. Let's go back to our trigger and click the plus next to end. And now we have our 2 events. I'm also going to select these and drag them up so they're in the area where I want them. So when we begin overlap, we're going to check and see if it's the player. And if it's a player, set the visibility collision enabled. In this case, our other actor is going to be the player, and we want to compare it against the player. The nice thing is we can get player character. And now we have access to the player character. We can plug this in here, and that should be our check. So if we get the player character and we are beginning overlap, we're going to set our visibility to none and set our collision to no collision. Let's repeat the same thing for our end overlap. We'll go ahead and grab all this code, copy it, and paste it. Go ahead and hook it up the end. When the other actor is our player, set the visibility, set our collision. Let's go ahead and compile and save. Let's go back to our map, and let's put that door in. I'm going to go ahead and replace this wall. Now we could delete this and drag in our new door, or when the other actor is our player, set the visibility. Let's repeat the same thing for our end overlap. We'll go ahead and grab all this code, copy it, and paste it. Go ahead and hook it up the end. When the other actor is our player, set the visibility, set our collision. Let's go ahead and compile and save. Let's go back to our map, and let's put that door in. I'm going to go ahead and replace this wall. Now we could delete this and drag in our new door, or with our new door selected in the content browser, we can right-click on the item we want to replace. Choose replace selected actors with, and it's our current selection. Now you can see it's been replaced with our new door. It's our new blueprint. Now at this point and going forward, I'm going to recommend you go to change play mode and settings and change it to current camera location. What this allows to do is to start from wherever our camera is rather than the beginning, and we won't have to keep redoing the items we've done to get to our next section we're testing. I'll hit play. Now we should be able to walk up to our door. When we hit the trigger, it hides. We walk through it. If we look back, once we've left the trigger, it's gone away. And now our door is opening automatically when our player walks through it. Now that we have a working door that we can walk up to, that will trigger and then open and close as we walk through it, let's consider the fact that blueprints are intended to be reusable, and we mentioned before the parent-child relationship. We're going to have other doors inside of this project, doors that may open from a trigger or a switch or some other method. Right now, this door is fixed so that way when the player walks up to it, it opens. It uses a box collision. The door itself only really needs to do 2 things, open and close. What we're going to do is convert our door into a more generic opening and closing door, and then create children that have specific functionality that we can easily open. Or some other method. Project. Doors that may open from parent-child relationship. Consider the fact that blueprints are intended to be reusable, and we mentioned before the parent-child relationship. We're going to have other doors inside of this project, doors that may open from a trigger or a switch or some other method. Right now this door is fixed so that way when the player walks up to it, it opens. It uses a box collision. The door itself only really needs to do 2 things, open and close. What we're going to do is convert our door into a more generic opening and closing door, and then create children that have specific functionality that we can easily reuse. Let's go ahead and open up our door. If we don't have it open already, let's go ahead and create our custom events that we're going to use instead of the overlapping of the trigger. We'll right-click Custom Event, and we'll call this one Open Door. We'll do the same for the Closed Door event. Now looking at this, the overlap event and its specific code is going to be unique to the door that uses the overlap trigger. So we're going to want to hook up our closed door event after the fact, right before our set visibility is. Let's do the same thing for our open door after the fact, right before our set visibility is. Let's do the same thing for our open door and hook it up where set visibility. Now I'm not going to delete these yet because I want to simply copy and paste them into our trigger door. Let's go ahead and compile and save this. We'll go back to our starting map. Right-click on our BP door and create a child blueprint. This one, instead of being BP_map, right-click on our BP door and create a child blueprint. This one, instead of being BP_door child, will be door trigger.
Child?
And create a child blueprint. This one, instead of being BP_door child, will be door trigger. Let's open this up. We can delete anything we don't need. Now that we have our child created, let's go ahead and clean up the original door a little bit more and move our code over. Go back into the blueprint door, clean up. We can delete anything we don't need. Now that we have our child created, let's go ahead and clean up the original door a little bit more and move our code over. Go back into the blueprint door. We'll grab the information out of there for the overlap and cut it out. And then we'll paste this inside of our door trigger. We'll do the same thing with the end overlap. So we'll go ahead and select those and cut it out. Control X for cutting on the keyboard. And then pasting. Now we have the events that'll trigger when we start our overlap and end our overlap. Let's go back to our parent door and delete the trigger out of there. We'll compile and save and go back to our child. Control X for cutting on the keyboard. And then pasting. Now we have the events that'll trigger when we start our overlap and end our overlap. Let's go back to our parent door and delete the trigger out of there. We'll compile and save.
Oh my God, you're going way too fast.
Control X for cutting on the keyboard. And then pasting. Now we have the events that'll trigger when we start our overlap and end our overlap. Let's go back to our parent door and delete the trigger out of there.
Okay, so door no longer has trigger.
Compile and save and go back to our child. You'll notice when we come back into our trigger door, we now have 2 warnings. That's because that trigger component is no longer here. Let's fix that by going to add, typing in box collision. We'll go ahead and select that. We'll rename box collision to trigger. We'll notice we get an error. That's fine. We can ignore it because we'll be fixing that in a second. We'll click on the trigger, go back to our viewport, move it more towards the center of our door. We'll resize the box extent to something more like 100, 200, 200.
Blah, 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 blah. What? Oh, okay. Viewport this.
Resize the box extent to something more like 100, 200, 200. And maybe move it up. You can, of course, adjust this.
That seems a little big.
Now we have something similar to what we used before. Move it up. Something more like 100, 200, 200. Size the box.
Stormy, wait. Oh, you spelled it wrong. Hi, Stormy. How you doing? Try again. Door frame. Are you? What am I doing wrong? You had an S. Wrong Wales, but nice try. Good effort. Alright, why is your box size so much different than mine?
Extent to something more like 100, 200, 200.
Oh, box extent, not
maybe
scale. Box extent. There you go. Guess there are no bush matches. Silly Stormy.
You can, of course, adjust this however you'd like, but now we have something similar to what we used before. Let's go ahead and compile and save. Go back into our event graph. You'll notice our errors are gone and our warnings are gone. Now, the only issue here is how do we actually call this closed door?
It tried to. There was a brief moment where you could hear the background audio start and then it stopped. For some reason, sometimes the double audio, it either comes at weird times or it gets cut off, and very rarely it just never happens at all. I still have no idea why. Yeah. Don't know. 1 second. But yeah. That's... Yeah, no, I don't know.
An open door event in our parent. Well, we would do a call to the parent. So if we go back to our door, gone. Now the only issue here is how do we event graph? You'll notice our errors are gone and our warnings are gone. Now
nope, mine are still there. Oh wait, compile. Hey, all right.
The only issue here is how do we actually call this closed door and open door event in our parent? Well, we would do a call to the parent. So if we go back to our door trigger, it's called open door when we want to open it. So we'll type in open door. And we have calling the function and the event open door. So we'll do the event open door. We can right click and we can add call to parent function. Choose this option. And now whenever we trigger the overlap, we're going to check the action and the event open door. So we'll do the event open door. We can right click and we can add call to parent function.
Add call to parent function. Oh.
Choose this option. And now whenever we trigger the open door,
why did yours
like calling delete? The function and the event open door. So we'll do the event open door. We can right click and we can add call to parent function.
Oh, they just deleted it. Got
Choose this option. And now whenever we trigger the overlap, we're going to check for the player like before and then call the parent's open door function, which we can see here. We'll then set the visibility and open the door. Let's go back and do the same thing for our closed door. We'll go ahead and right click, choose closed door. Remember, we want the event because we're going to override the event and call the parent function. Go ahead and delete the closed door. Hook up the parent's closed door. We'll compile and save. Go back into our map. Remember, we can replace. So select the door trigger. Select the door in the world. Right click, replace with the door trigger. Now the door trigger shows up. Let's go ahead and play.
That right click, replace is not there.
Hook up the parent's closed door. We'll compile and save. Go back into our map. Remember, we can replace. So select the door trigger. Select the door in the world. Right click, replace.
Wall Street. You gonna make the next Stardew Valley? Probably not. See, that's duplication. Why can't I do? Okay, the replace thing, the replace things that. Oh, now you show up. What is it? What? Why? Why were you not showing up before? I'm so confused. Okay, sure, fine.
Place with the door trigger. Now the door trigger shows up. Let's go ahead and play test. Now you should be able to walk through the door and it'll trigger, walk away, and it'll close. It's duplicated the same functionality as before, except now our base door just handles the opening and closing effects, while as our door trigger
mine doesn't work.
Handles opening and closing using a trigger.
What did I do wrong? You got a new emote for the golf fans. Oh, Jesus Christ. Yep. Yeah, there's a lot of people that aren't going to know what that is. Yep. Oh, dear. Just figured golf was big on Twitch. Uh-huh. Right. Hype shock. Uh-huh. What? Oh, you know what? I don't think I linked these. Yeah, you need to get linked to there. You need to be linked there. Okay, do that. Compile, blat. Try again. Hey, look, a door open. Hey, look, a door closed. Hey, look, a door open. Oh, God. Oh, my God. Alright, cool. I'm done.
For function. Now that we've looked at communication within a blueprint, we're going to take a look at how we can have two different blueprints talk to each other, but still maintain the reusability that we gained by using blueprints. When communicating with objects, we need a reference or a variable to talk to, something that gives us that bridge or connector between the two. Up to this point, we have used direct references in the level blueprint or variables inside of the same blueprint. What we're going to accomplish here is in our next room, we have a lever. The lever is going to open up a door and let us into the next room. The lever and the door are going to be separate, therefore we need some way to bridge the gap. We have our base door that we created in our last module, so let's go ahead and right click and create a new child blueprint. We'll call this one BP_door lever.
Oh, lever. Door lever.
Remember, we created these so we could easily reuse the functionality of simply opening and closing the door and change the method of actually calling that. Let's open it up, dock it if it hasn't been docked, and let's go into the event graph. I'm going to delete any of the nodes that are in there since I don't need them.
Bye.
So how are we going to accomplish this? If you haven't already, I'm going to clean up my display so that way I only have my map and my door for the level.
Yeah, I don't care. I'm keeping it open. You can't stop me.
In the world, you can click on it in the item in the world, or in your blueprints folder, open up BP lever door. Inside of this door, we have a lever activated event. We also have one for deactivated, but I'm only concerned about the activated one. If we go into our map, remember I've got mine set up to current camera location, and I'm looking at the lever now. Let's test this out and see what happens when we interact with it. If we walk up to the lever and click our left mouse button, we'll reach out, the lever will go down, and we see lever activated at the top. We could also deactivate it, nothing happens, and test activating it again to make sure it works. So we know that when the lever activated event is called inside of our blueprint here for our lever door, we want the blueprint door lever to be told to open. We need a connection between the blueprint for our lever and the blueprint for the door. Let's go ahead and create a new variable. We'll click the plus button and we'll call this door to open. Now, what type is it going to be? Now, the BP door lever is what's going to open. However, we also have, if we go back to our map, the BP door. We can use either one of these. It's not really going to matter because what we're going to care about is the calling of the open and the close event. But I'm going to use the door lever so I can show you how you can override an event and then call the parent as well. So we want to talk to the BP door lever. Go back into our blueprint for the lever itself and the door to open variable. Let's change it to that door. So BP_door_lever. We can see here. And then what are we going to want to choose? Object reference is something that's in our level itself. It's something that exists. Class is the class itself, or what makes it up. So the defining code behind this item. It's what we can see inside of our content browser. And then soft object and soft classes are something we're not going to touch upon. What you're going to want is the object reference. We're going to want to talk to something inside of our world. Next to this, we have an I. This means the variable is public or not public. And it's also editable or not editable on an instance of this blueprint. Instances are the copies of the blueprints that go into the world. This wall is an instance. This wall is an instance. This wall is an instance. The trigger is an instance. The floor is an instance. These are all unique copies of these original blueprints. So that means this item and this wall are all unique. Going back into our lever, let's go and click the eyeball next to our variable to make it instance editable. You can also click on the variable, and on the top right, in our details panel, we have access to the different variables, instance editable being one of them. Let's go ahead and compile and save this. We'll go back to our map. In our map, we can click on the lever, and in our details panel, if we scroll down, we now have a new variable under default called door to open.
Where are you in default? Oh, default. Default! It's right there!
Open. And it's asking us what door do we want to open. If we click on the drop-down list, we'll get a list of all of those items in our world we can open. We haven't added any of these trigger doors yet, so nothing shows up in our list. Well, let's do that. Let's go ahead and grab this wall here next to the lever. Let's choose our door that we want to replace it with, our lever door.
Now let's do a stupid thing again. I don't know why you do. Okay, why you do this to me? Okay. Select this, select that, click that, and now I'm so confused. Okay, sure, whatever.
Now let's click on our lever. Go back to the door to open list and click on it, and now you can find that door in the level. We can select it, and now they are connected. You also have the ability to find that item in our viewport or an eyedropper, which lets you click on available items in the world instead of on the list. Now that we have that connection made, if we go back, we can select it, the door to open list, and click on it.
Door. Oh, I did the trigger. Okay. No, that's. You go there, replace. Get out of my way. S, M, or T.
And now you can find that door in the level. We can select it, and now they are connected. You also have the ability to find that item in our viewport or an eyedropper, which lets you click on available items in the world instead of on the list. Now that we have that connection made, if we go back into our lever, whenever this event is called, so whenever we trigger it, now we want to talk to that door and open it. So now that we no longer need our print string, I will delete it. We're going to grab our variable out of our variable list and get it. This should be very similar to when we worked with components before. We use these variables to communicate. Let's drag off of our door to open and type in open door. And now you can see you can call the function open door. We'll go ahead and do that. We'll hook up our code. And now whenever the activated event for the lever is called, the open door event will be called on whatever we've set up in our door to open. We can compile and save. Let's go back into our map and let's test this. We will walk up to our door, make sure we can't activate it that way. We'll go back to our lever. We'll click our left mouse button. The lever is activated and our door opens up. We can now walk through it. You'll notice it doesn't close behind us because we're not using a collision trigger. We just simply use our lever. The nice thing is our lever does have that deactivated event. If we wanted to, we could also call the close event and close the door if you deactivated the lever. Now going into our door lever, you'll notice it's completely blank. The parents event is being called by default because we're not overriding it.
I'm sorry, what was that?
It does have that deactivated event. If we just simply,
The voice sounds familiar. This is, Matt, was it Matt? Where is he? Matthew Wadstein. They have done a lot of these tutorials that I'm going through. But, Sudokid, hello, how are you doing? Badger just talking. I'm just a badger, but I didn't have a badger, so I painted a doge. it's the best I have at the moment. Makes good. Yeah, I've been enjoying them. And that and a few of the others used to be employed by Epic to make this. Oh, so no longer there. Interesting. Regardless, they have been a great resource so far. Yeah, several of them. Actually, I think he was even the one that did the begin ones. The begin play ones. Was he the one that did these?
Welcome to begin.
No, that was not them. Okay. Those ones are really good. I like those a lot. But yeah. How are you finding EU since the move from Unity? Oh, that's a weighted question. You've not watched any of his epic tutorials, you watch his YouTube stuff. Ah, okay. Well, the tutorials that I found on here have been very good. I will have to go and look up their actual YouTube at some point. To answer your question, definitely the few pros and cons, but there, I would, I can't deny there have been a couple moments of, it's like, oh, what have I been doing with the past 10 years of my life? There's some really cool stuff, I gotta admit. So I'm very very eager to keep diving in. And also, why am I clipping off? Okay, I gotta figure out why I'm clipping over that soon. Eh? 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 Slightly less clipping. Anyway. He's a very robust game engine. Yes. I am very curious. So, one of the things that I find very interesting is the amount of stuff that already exists. Like, just the notion of, it's like, oh, you create this this character and you just, oh, you want to jump, just call jump, as opposed to having to write other code that you would normally have to do, like in Unity. And just so much stuff just is already there. It's insane. However, I am also very curious of how they deal with the amount of overhead, because it just seems like there was so much stuff. Like, if you have all of these variables and these all of this stuff that you aren't using, well, it was going to be overhead. I mean, there's memory involved and such as that. So I'm very curious of how it handles all that. But I haven't gotten into the nitty-gritty of that. How long have you been making games? making game, not terribly long. Been using Unity for over a decade. But that's a lot of back-end dabbling, tinkering, playing with voxel stuff, I was actually trying to get a dual contouring voxel engine to work. I haven't touched that in a while. Dabbling with various AI things. Tried Gope for a while. Got Gope working for a bit. Was really working on unsupervised neural networks, genetic algorithms. That's a lot of fun to me. I'd like to get back into that at some point. I dabble with various components. I am more of a backend developer. Historically, my trade has been enterprise development. Been working with Java or PHP and some other things for a very long time. But yeah, C++ over C# on a personal level. Oh, I can't argue with you, but I also don't know C++ that well. I know C# pretty well now because of Unity. I'm very eager to get back into C++. It has been a very long time since I've done C++. But I also am going to really focus on the blueprints for a bit. And learn the engine and dabble with C++ as it comes. I don't want to just full head dive straight into only C++. I want to make sure that I go across the whole thing. The move from Blueprint to C++ is rather simple. That's what I'm understanding. There actually is a course that I'm going to be doing in the next... It's on my list, and it's pretty quick on my list. Where did it go? I thought I did this one. Didn't I do this one? Why are you on? Yeah, I already did that one. Let's talk about C++ for blueprints. Yeah. Yeah, this was going to be these two, C++ for blueprints, and then balancing blueprint and C++ in game development. These are two that I'm going to walk through at some point, but I want to go through this this blueprint communication. One is what I'm working on right now. Very little memory management has to be done in C++. In UE. Yeah, I've noticed that. That it seems like they in the begin play they mentioned that a lot of memory management is already done for you, which is very interesting. Rather bad at balancing blueprints in C++. Ah, well, if you want, I can send you the link to this. And I have not run through this tutorial yet, but in this course, you'll learn how to make the most out of Unreal Engine by utilizing blueprints C++ in ways that complement their individual strengths. By the end, you'll be able to assess which option best fits your needs in your own projects. But yeah. Timers are something you do need to manage, by the way, just a heads up. I will try to keep that in mind. Yeah, I've got a lot to learn. I'm still very new, obviously. Yeah. Eager, but still very, very new. So if you attach a timer, make sure you clean it up at the end of play. Is that also from a blueprint standpoint? Even in a blueprint, you're going to have to clean it up? Or will the blueprint version of that take care? Is that just a C++ thing? Where was I? Not sure, but it would do it in blueprints as well, just to be safe. Okay. I have no idea how to do that. I don't know what would even be for cleanup. And I don't think I've actually used timers yet. There was a delay that was exampled a couple times. But I don't think any of the tutorials have gone through timer. I don't think I've encountered that one yet. But had it crash your game for a couple days because it happens in a separate thread, so it doesn't really tell you what's going on when it crashes. Oh, yeah, those are fun. Yeah, that's an area that I'm actually very curious to figure out how it all behaves, how it works, is how this whole blueprinting system works with multi-threaded. Because I've done multi-threading in C# and Java, so very curious to learn that. No, don't do much blueprint stuff. Gotcha. Oh. I will be learning this. Yeah. Your blueprints are super basic. Gotcha. From my understanding, it's pretty reasonable to go both directions. And, yeah. You would do most of your UI stuff in C++. Ooh, that sounds painful. I remember doing UI stuff in Unity before, like, one of their early UI tools. You had to write everything in code. I am very happy for their new UI tools. I have not gotten into Unreal's UI tools. At a brief glance, it looked like they might be somewhat similar to Unity. I am hoping that they are similar enough, though, because Unity's new UI toolkit is very impressive. I have instantly fell in love with it. It is really, really good. So I will be very happy if it at least has some similarities. It's very CSS-like driven. I mean, they actually have CSS files, and it's yeah, very, very WYSIWYG. It's a bit harder to do blueprints to C++ while going C++ to blueprints is really easy. You want to use Common UI plugin in UE. I believe that's what was mentioned. Yeah, Common UI I've heard that before. I haven't touched UI stuff really yet, but I'm sure that will be coming along my learning process here. Yeah. Common UI gives you controller support in the UI out of the box. Controller... Oh, console controllers, I'm assuming you mean? Yeah, gotcha. Yeah, I, even for... That's a big one? Gotcha. Even for just my first little game or whatever, I'm not targeting consoles, but still, I will probably look into the common UI. I've heard that before, and it looks like I thought I saw it referenced in a couple of tutorials. Add styles, nice. Yeah. Yeah, Unity's UI toolkit is very awesome. Stormy, you don't need to be washing your golf balls right now. but thank you, Stormy. So just if you want to say use Xbox controller, you want to comment. It's silly, Stormy. Oh, just if you want to use say an Xbox controller, you want common UI. God dang it, Stormy.
One and only Stormy Fatten one critters. They were dirty.
Oh, Stormy. But yeah, and there's a duplication. I don't know how to fix the duplication.
One and only Stormy Fatten one critters. They were dirty.
I would love to be able to fix OBS's duplication. I have tried so many different things. It's just not go away. Glad Magic gets to laugh at your but yeah, I definitely appreciate the recommendation, PseudoKid, on Common UI. I'll definitely be looking into that. One step at a time. Where was I? Oh, it's getting late in the day and my brain is shutting down and I'm barely halfway through this tutorial. Oh, man. Alright. Where were we?
Save. Let's go back. We'll go back to our lever. We'll click our lever.
I did that.
You'll notice it doesn't close behind us because we're not using a collision trigger. We just simply used our lever. The nice thing is our lever does have that deactivated event. If we wanted to, we could also call the close event and close the door if you deactivated the lever. Now going into our door lever, you'll notice it's completely blank. The parent's event is being called by default because we're not overriding it. Nothing is going on inside of the child, therefore the parent is going to get called and it will continue going up the stack for as many children and parents as there is. We can go by our BP door parent and override, and you can see we have a closed door there is. We can go into our functions list on the left.
Functions list. Okay, I see. Stormy, where I am. PseudoKid, to your question earlier about the overhead of all the data in like character controllers, UI does have a much bigger footprint, but the bigger the game gets, the more you use all the values. Yeah, that's kind of what I figured. It does kind of explain why Unreal typically has a what's the right word? Reputation for needing beefier PCs. Because if there's not much optimization in your smaller components, then you're going to have a lot of overhead and a lot of wasted memory. But yeah, much more AAA focused. Regardless of where it's focused, it's I'm definitely wishing that I had started to learn it earlier. I am absolutely like kicking myself in the tail that I didn't know / start getting all of their free assets. So I didn't use Unreal. I didn't use Unreal Engine, but I had created an account back in 2016, and the amount of assets that I could have had just makes me want to cry. Free assets in the first Tuesday of the month. Oh, good to know what day it is. I did not know that. Somebody's question is, pizza healthy food for pastures? You mentioned making pizza before, and obesity is no joke for house pets. Hey, I'm not a house pet. Hey. And usually I'm making pizza for Bun, not myself.
Override, and you can see we have a closed door, which is by our beefy door parent, and open door, which is our beefy door parent. If we want to override the open door, we can do that. Let's go ahead and hook up a print string to this, and we'll type something like override. We'll go ahead and compile. If we were to play it right now, you'll find override the player start, alt player start. It does not override the player start using the option in the top unless you're in the viewport. Let's go ahead and play it in the viewport and test out our overridden event. Walk up to the switch, activate it. It should say override and not actually open the door. Going back into our door, we can see it's doing exactly what it should do. We are overriding the parent's open door event and printing a string. We can again right-click on the event, add call to parent function. We can hook this up, and now it's going to override it in the child, print out a string, and then go ahead and call the parent's open door.
Oh,
Go ahead and go back to the map and test out that it's working. Walk up to the door.
I was wondering how you call the parent like that.
It says override, and the door itself opens up properly.
Nice.
I'm just going to clean up the print string to get rid of this mess. This is useful if you want the children to do something special, maybe a firework effect went off or something else triggered, and you still want the parent's functionality.
Story, hungry, let's talk food. What kind of food do you like the most? Pseudo kid, burbs, no problem with the burbs. Would say your faves are Mexican, Chinese, and pizza. Oh, my faves change too regularly. No. I eat a lot of chicken things, but yeah, Mexican, Chinese are both good. I like Thai. Yeah. Well, I like a lot of different things.
Exposing variables to the end. You want the children to do something.
No, not vegan, no.
Something special, maybe a firework effect went off or something else triggered, and you still want the parent's functionality. Exposing variables to the editor is a great way to allow communication between two items that designers can use while setting up our level. Up to this point, we have been able to be very specific about the items we want to use for communication, but sometimes we don't have that option. In some cases, we end up with a reference to an object higher up in our parent-child relationship chain, but we need to talk to it and treat it as if it was something more specific, and that is where casting comes into play.
I imagine that I'm going to completely grasp this, because this is...
Casting is the concept of treating objects as something specific, and takes full advantage of the concept of the parent-child relationship that we've already seen. A stack mesh actor is a child of actor. A character is a child of pawn, which is also a child of actor. The parent-child relationship that we've already seen. A stack mesh actor is a child of actor. A character is a child of pawn, which is also a child of actor. When working with blueprints, sometimes we get back an object higher in our chain than we want. And by
Stormy, let me so much differently because you must be silly Stormy.
Using casting, we can treat it as something else more specific. Let's go ahead and look at our next area. Our next area is simply going to have a door that once we have triggered it, will open up. Our trigger is going to be literally a button we can stand on. However, we want to make sure that that button only triggers when we, the player, stands on it. We also might want to do a check for a key. Now, if we were to test this out, we can see we have a few balls rolling down and landing on the trigger. The player themselves can also land on the trigger, but nothing's happening. If we go back into the editor and we click on this blueprint, we have the blueprint trigger, and we can edit it either inside of our content browser here or inside of our outliner. And let's set up a simple check for what is going over our trigger. Selecting our box collision, we can scroll down, we can do the begin overlap, and we can print out what is connecting to us. We'll connect the print string node, and we'll connect out the other actor. Clean this up a little bit. We'll compile it, go back to the map, and we'll play it again. And on the top left, whenever something goes over this item, it'll tell us. In this case, it's our blueprint communication character. Or if we get out of the way of the spheres, we can see our trigger balls are colliding. So how do we make sure it's only our character? If we go back into our blueprint, we have our other actor. When we mouse over it, at the top, it says other actor. It says it's an actor object reference. It currently has no value. And then we're printing it out using the get display name. If we were to compare this to our character, so other actor, we'll do an equal. And we'll go ahead and we will plug in our character. So we'll get player character. And we'll plug this in. And we'll print out if this is our player character that is overlapping. We can get rid of the get display name. We'll compile and we'll check this again. When we walk over it, you can see it's true. And you see when our ball walks over it, it's false. Now the reason this is working is this node here. If we look at the inputs on the left-hand side, we can see it's an object reference and an object reference. So we're finding out what object makes up this character and what object makes up this actor and then comparing it. So we're going up our child's chain. Now, while this is good for the player character, because we can get the player at any time, what if we actually wanted to see if this was the ball overlapping us? Well, we can't just get the ball. We'd have a reference to the ball itself, and it would be of the type ball. And that's where our casting can come into play. We're going to look at this by adjusting our code by adding a key to the player. And we need to talk to the player itself as the player, and not as a generic object or character or an actor. Let's go back to our map. We're going to find our player itself and open it up. Dock it if you need to. Let's add a simple new variable.
Where did you go?
Itself and open it up. Or an actor. Let's go back to our map. We're going to find our player itself.
PPO, communications character.
And open it up. Dock it if you need to. Let's add a simple new variable. We're simply going to call this
okay, got it.
Has key. And a Boolean is fine. If it's not Boolean, please change it to that. Let's compile it, and we can see has key is currently false. Let's go back into our blueprint for the trigger. Let's take our other actor, which we have already determined is probably going to be our player character. And let's type has key. And you'll notice, well, it doesn't have a key. And at the top, you'll notice it says actions taking an actor object reference. Our communications character is a character, and it's an actor, and it's an object as we go up the hierarchy. But the specific version here is a blueprint communications character that contains our has key Boolean. So we need to treat this item as the blueprint communication character. Let's go and delete some of this code here. Other actor, we'll drag off and we'll type cast. And this will give us all of the available casting options. Well, we know it's blueprint communication character. I'm going to type character. Now you can see everything that has character in it, including our parent character class. But we want our blueprint communications character. You'll notice it hooked it up automatically. If it didn't, make sure it's hooked up so it runs. Now, as the blueprint communication character, we can look for has key. And now you can see we can get and set the has key. So we'll get has key, hook this up to a branch. And now, if this is a character overlapping us, and they have the key, we want to do something. We've already set up this code before in our lever blueprint, so we should be able to duplicate it here. Create a public variable. We're going to make this equal to our door, so we'll just type in door to open again. This time we can just set this to a generic door. So we'll do BP underscore door. We'll go ahead and compile and save, and we'll expose it. Let's go back to our starting map. We'll go ahead and compile and save, and we'll expose it. Let's go back to our starting map. Let's go ahead and click on our trigger here. You'll notice we don't have it
Map trigger
showing up on our BP trigger. If we go back into our BP trigger and we compile and save, and now go back, now you'll find it's open. If you ever notice that something doesn't seem right, maybe you haven't compiled it, maybe you haven't saved it, it will not update references and variables and connections until it's been compiled and everything else that knows about it has been updated. Now we need a door to open. If we click on our list, we can see we have 2 doors already here. If we want, we can go and put our door in now. So we'll put our door in, let's say right here. We want a BP door. Doesn't have to be specific for this trigger. We're just going to go ahead and use the BP door itself because we just need to open and close it. We'll right click, replace with the BP door. It's a recently placed one. Or if you click on it, we can replace it with the selected. Now we have our door here. This one's the 33 is the number. Yours may be different depending on how you did it. This is one advantage. You can also go in and rename this. We'll name this trigger door. We'll go back to our trigger itself that's on the floor, select it, and we can do trigger door, or use the eyedropper and clicked on it. Now the trigger and the door are connected together using our public variables. Now how do we do our key check? Inside of our blueprint trigger, inside of here, we're checking if our character has the key, and if so, we're doing something. Grab our door to open, get it. We're going to do open door. We'll hook this up to our true, and then we'll test. We'll hit compile, save, go back to our map. We'll go ahead and let a few balls drop through. Remember the balls, save, go back to our map. We'll go ahead and let a few balls drop through. Remember the balls are triggering. We did see that before. When our player goes through, we can check. And the door, well, the door didn't open. The door didn't open because inside of our trigger, we are checking to see if our player has key. Inside of our player, we have the variable, but it's set to false. Let's set it to true. Compile and save. Go back into our map. We'll go ahead and hit play to test again. We'll look at the door, watch the balls land on it. They shouldn't work. Our player should be able to go over it, go back, and the door is now open. By using the casting, we're able to treat one item, in this case an actor, as another, our Blueprint Communications character, and then work with it. Our Blueprint Communication character has this variable. The items above it do not. It's unique to this one and any of its children. We've kind of seen that before with the events like the opening door and overriding the parent. So this is where casting will come into play. Anytime something is returned as an object type that is something that you don't want, and you need to work on it more specifically, that is when you'll use casting. It's also useful if you simply want to do a quick check on if something is something. You can cast, and if it is not, it will fail, and you can do something appropriately. However, continually casting, let's say we want to check and see if the character or the round ball or maybe another character, or even if we want the AI to open it, are all available and allowed to open, we'd have to cast. If it fails, check again. If it fails, check again. And that can lead to a lot of bloated code. And that's kind of where our blueprint interfaces come in.
I assume this is going to be like class interfaces.
Blueprint interfaces are a great way to generically allow communication between objects, including different types of objects. For example, I might want to communicate with an object and tell it that I want to interact with it, but I only want the objects that I can interact with to actually do something, and everything else to ignore that request. Up until this point, we've actually been using a blueprint interface. Whenever our character tries to interact with something, it uses the blueprint interface and passes along that message. I'm going to open up my trigger here. We can see in our trigger, when we overlap, we cast to the character and then we try to do something. If I had more than one item that could overlap this trigger, for example, maybe the balls or a artificial intelligence character, but I didn't want them to be able to push a cube over it, I might have to do things like not cube or character or box or AI and have a bunch of different casts to check and see what's overlapping. Using interfaces, we can just simply have one check. Inside of our character, we get all the items that are overlapping our overlapping capsule, and then we tell it to interact with. interact with is our blueprint interface event. I'm going to go ahead and do this for an example here. You don't have to follow along. And this is going to tell us everything that we are overlapping when we go ahead and push our left mouse button. When I walk up to our trigger, we can see on the top left, I'm trying to interact with the character, the trigger, and the wall. If we go over to our little button here and we interact with it, we can see the BP trigger and the characters being interacted with. But only one item is actually responding to us, and that's our lever itself, because that's the only thing that's implementing our blueprint interface. So let's look at how these work. In the next section of our map, we have a ramp. The ramp lets us get near the end. I'm going to want us to interact with an item, and that's going to make the ramp appear so we can get to the next section. Down here in the corner, in our blueprint folder, I have BP_trigger pickup. I'm going to drag it in and drop it, and this will be the item that we're going to interact with in order to trigger the ramp going up. Let's go and double click to open it up. Now, we may have ran into this before. If you haven't, this is what happens when you have a blueprint with nothing in it. May have ran with in order to trigger pickup. I'm going to drag it in and drop it, and this will be the item that we're going to interact with in order to trigger the ramp going up. Let's go and double click to open it up. Now, we may have ran into this before. If you haven't, this is what happens when you have a blueprint with nothing in it. It's just data at this point, and it tells you this is a data-only blueprint. Go ahead and open the full blueprint editor. Now that we're in the normal blueprint view, let's go ahead and look at the interface event. Inside of your class settings for your blueprint, you have a section called interfaces. Inherited interfaces, items from the parent, and then implemented, ones that this blueprint implements. If we click the add list and we scroll down, we can find one created for us, BPI_learning_kit_player interactions. We'll click on that. Now compile and save just to make sure everything's updated. And on the left, you can open this if you need to, is our interfaces drop down. And it has an interact with event. Now click on that. Now compile and save just to make sure everything's updated. And on the left, you can open this if you need to, is our interfaces drop down. And it has an interact with event. Now we can right click and implement the event. And it's going to go ahead and automatically set it up for us. This event, whenever it is called from something else, is what's going to fire off. This is our blueprint interface implemented event. Let's just go ahead and set up a quick test to make sure this works. We'll drag off and do a print string, and it can simply say hello. We'll go back into our map and we'll test. Now when I get close enough and interact, it should tell us in the top left hello, and tell us the name of the item, which is blueprint trigger pickup. I'm going to go back into my character and delete that debug code, since we now know it's working, and hook this up. You should go ahead and do the same if you did that. And let's go back into our trigger pickup. Now what do we want this to do? Inside of our map, we're going to take this ramp and we're going to move it into place. We're going to go ahead and need this location information, so that way we can change the actor's location to this position once we interact with our item. So go ahead and write down this location or try to remember it. I'm going to go ahead and say we interact with our item. So go ahead and write down this location or try to remember it.
Ooh, does Unreal not have that ability? That's a one up on, oh, there it is, copy. Yeah, okay. I don't know why they didn't do that.
I'm going to go ahead and set up the code now. We'll go back into our trigger, delete our print string. We're going to drag off the event interact with and type in set actor location. And this will let us set the location of any actor that we want. So we needed the X, Y, and Z. So I have approximately 1340 on the X, negative 2400 on the Y, negative 70 on the Z. And I'll go ahead and set those values in here. So now that we know where it's going to go to, we need to know what to move. We're inside of a separate blueprint. Let's go ahead and set up a public
because you
variable.
can't paste into that. Ah! I accidentally closed the window.
We'll change this one to ramp, and we'll set the type to be actor. Go ahead and set up a public variable. We'll change this one to ramp, and we'll set the
public variable.
The type to be actor. Since we're simply setting an actor's location, it'll work. We don't have to be exact. Make sure it's an object reference, because it's the item inside the world, and turn it on as public. Let's go ahead and compile and save. Let's go back to our starting map. We'll click on our pickup item, and we can see we have a ramp. It's any actor in our world, so let's use the eyedropper to select the ramp itself. Let's go back into our trigger pickup. Let's hook these two items up. And
pick up. Ramp.
Now, when we interact, we should be able to set the new actor location. Let's go back and compile into our map, select the ramp. Let's move into the move tool and just simply drag it below the world so we don't see it anymore. And let's test. Now, if we get close enough and interact, our ramp pops into place and we can move up to the next section. So that was how we use a blueprint interface, but we didn't create one yet. We also didn't look at if we want to pass variables. So how do we do that? To create a blueprint interface, you can right-click anywhere in your content browser, go to Blueprints, Blueprint Interface. I'm going to name this one BPI_inventory. And what we're going to do is this anywhere in your content browser, go to Blueprints, Blueprint.
Oh.
Interface. I'm going to name this one BPI_inventory. And what we're going to do is this will check the player's inventory to see if they have an item. And then if they do, then we will interact with the pickup. Let's open up our blueprint interface and dock this and take a look at it. This should look familiar. We have our blueprint graph, and then we have some variables and some properties. One difference is this is read only. You're only defining the signature or the definition or how this basically gets called, not what it actually does. Let's rename this to has item. You can click on it or right click and rename or use the F2 key. The intention of this interface is to put on something that has an inventory. And then we want to use the has item function to check and see if it has a specific item. We're just going to use a string to check and then return back yes or no. So we need our input and we need an output. You'll notice once you do that, we now have a return node with the output type, and our input now has an input variable. Go ahead and reselect it if you need to. Sometimes once you put in the output, it's going to go and unselect it. I'm going to make this a little bigger so we can see it easier. Now our input is going to be item, and our output is going to be has item. Our item itself is simply going to be a string. This is going to be more robust for a actual full implementation. But for example, we're just going to check with a string name, and has item is going to return back the Boolean, yes or no. We'll go ahead and compile and we'll save. Now, this is going to be on our character.
Stormy.
So let's go back to our blueprint communications character. We set our interfaces in the class settings, and we'll simply add our
interfaces, class settings.
Communications character. We set our interfaces in the class settings, and we'll simply add our new interface, BPI_inventory. You can have multiple interfaces without an issue. We'll compile and save to make sure our blueprint has that information. Now on our left, we have the information for our interfaces. We have the event from our Learning Kit interactions and our function from our has item. Now if we go ahead and right click on has item,
All right, what do I do?
We'll compile and save to make sure our blueprint has that information.
BP_communications, class settings, BPI inventory.
Information. Now on our left,
BP functions. What am I missing? Why did I miss? This didn't get compiled. Okay, cool.
left, we have the information for our interfaces. We have the event from our Learning Kit interactions and our function.
Why do I not have that?
From our has item. Now, if we go ahead and right click on has item,
I don't know why I don't have that one, but okay.
You'll notice we can't implement it. Because it has a return, it's automatically created for us as a function. And we can double click on it to open it up. And this is our check. We check and see if the item matches, and then we return back yes or no. Let's go into our trigger pickup. We're going to
wonder if I... No, trigger pickup as interact with... I don't know.
check and see if the object that interacts with us has a key, and if so, then we set the location. So if we drag off of this, we can type in has item. We can see it's a message. This is a generic message going to a generic object doing stuff. If we send this to something that doesn't implement this interface, then nothing's going to happen. That's the nice thing about message. However, if it does implement it, then something will happen. We're going to need to fill in our information. We need a target, an item, and then our return will go into an if. First of all, we need a target. How do we know what is interacting with this trigger pickup? Now, in our character, if we go back into the event graph, we can see it uses a special capsule. It gets anything that's overlapping, and then it checks them and interacts with them. What I'm going to do is actually modify the interface event that we're using, and I'm going to have it pass in the character that we're interacting with. So let's find that Blueprint interface. Let's go to class settings. Here's our Blueprint Learning Kit interactions. I'm going to browse to it, and now we have that interface. I want to modify it so that way we have an input. So I'll click on it in our functions list. We'll add an input. I'm going to browse to it, and now we have that interface. I want to modify it so that way we have an input. So I'll click on it in our functions list. We'll add an input. That input now shows up on the left side. We'll call this interactor. I'll drag this over. I'll click on the type. We'll do actor. Make sure we're choosing actor object type, object reference, because we want to pass in the actual item in our world, compile, and save. Now if we go back to our communications character, you can see we now have an interactor to pass in. If you don't have one, it's going to be our communications character. You can see we now have an interactor to pass in. If you don't have one, it's going to be back to our communications character. You can see we now have
interact with interactor, okay.
An interactor to pass in. If you don't have one, it's going to be nothing. And if we go back to our trigger pickup, anything that's passed in will now be passed along.
Interactor.
So our interactor can be hooked up to our target on our has item. For our item, I'm just going to type in key. Again, this is just a quick check. We'll move this over. We'll drag off of our has item, type in branch, hook these items up. If we have a return of true, then we're going to go ahead and set the actor location and move it. Now, anything we want to send this has item to, we'll check and see if we have a key, and then go ahead and go on. In our communications character, let's go back to our has item location and move it. Now, anything we want to send this has item to, we'll check and see if we have a key, and then go ahead and go on. In our communications character, let's go back to our has item interface here on the left. Since this is just an example, I'm just going to make a quick check that will always work. We'll do equal, and we'll look for equal exactly string. We'll type in key. We'll plug this into our return. And now whenever has item is called on our character, it checks if that item, which is passed in, is equal to key, and then returns back true or false if it is. Compile and save. And lastly, let's go back into our event graph for our Blueprint communications character. When we call interact with, let's go back into our event, and then returns back true or false if it is. Compile and save. And lastly, let's go back into our event graph for our Blueprint communications character. When we call interact with, who is doing this? We'll drag off interactor, type in self. So the person who calls interact with is going to be passed along as the interactor. We'll compile and save, go back to our map and test. And now when we go back up, it should talk to our character when we interact with it. Check and see if it has the key item, return true or false, and put up the ramp. And we can test.
Yeah, didn't put me where I wanted it to. Oh, big boom! Bye, Unreal. Alright, so it's probably me doing something wrong, but who knows what. Big boom. Bada boom. Oh, suckage. Alright, well, that worked. Okay, so curious fluke, cause also that's not working. I'll have to figure that one out. We'll go back and figure that out.
Test this by going back into our character
Later.
itself, into the has item. We'll change it from key to door to something.
Oh man, it closed all of my stuff. Oh. Yes, I would like to reopen them. Thank you. Do you want to reopen them and actually put them on? Can I select more than one? No, you're going to make me move all of these myself, aren't you? Yes, you suck. That's annoying. Okay. Event graph. No. Has item. Yes.
Into the has item. We'll change it from key to door to something random. Compile and check again. And now from key to door to something random. Compile and check again. And now when we interact, that has item check is going to be failing. And it's not going to work. Okay, let's go back and set this to key just to make sure if we need to do this again later, it works. One final thing I mentioned before is checking to see if an interface actually exists.
Oh, it actually loaded. Interesting. Okay, anyway.
Inside of our trigger pickup, our event interact with is being called on anything that interacts. What if we want to actually make sure it has that interface before we talk to it? Now, talking to something that doesn't have an interface is fine. If it doesn't have it, we're simply asking this target to do this if it can. If it can't, nothing happens. Let's drag off of our interactor on the event and type in implement. And we have does implement interface. We can choose any of our blueprint interfaces, and if the object we're checking has an interface, it'll return back true or false. We can use this to do a simple quick check on the object we're interacting with before we do an event, or you can also use it for filtering purposes. Maybe you want to go through 50 items that are overlapping you, but only check out the ones that maybe can be collected using the collected interface. Or maybe you have an interface that's just for the enemy. This can be used as a simple filter or a way to make sure you're only talking to something specific. Up to this point, we have been using direct communication and one-to-one when doing the communication itself. There are times when we might want to have multiple items handling an event, and this is where event dispatchers can be used.
But.
Sometimes an event might happen, and many things might want to know about it. For example, we're ending our level, or a player's died. We could create a section of code in our project that we designate to handle that, and then anything we might want to happen can be put in that one place. This, however, creates hard connections. We might not want those, as well as having code that should be in one location in another due to this one place handling everything. Rather than doing this, we can use an event dispatcher. It handles when the event happens and then lets everything else handle that event in a more appropriate place. You can think of this as like a list that can be subscribed to. We have an event, say the player dying. Anything subscribed to that event or list will be notified when it happens, and then those items can take care of those things individually. We're
Sounds like standard
end of our level,
observer pattern.
And what we need now is 3 collectibles to be collected, and then the final door open. As we collect those items, we're also going to have a user interface event that's going to update to show us how many are left. Let's go into our GM_BP communication. It's our game mode blueprint in our blueprints folder. This is a data only blueprint, so I'll open it in the full editor. Inside of our game mode, we've got a few things set up already. We have 2 events. One, when the collectible is spawned in, it will register itself and update our collectibles left variable. And another, once we collect the collectible, it'll go ahead and remove one from our collectibles left. And our collectibles left is simply an integer variable that will go up or down based on when we register them or collect them. Going back into our starting map, if we open up the BP_collectible, we can see this is set up in a fairly simple way using some of the methods we've learned already. We can see here our begin play events. After a short delay, enough time to give our whole world to spawn in, we get our game mode, cast it to the correct type, and then run the collectible register. So for every collectible...
This is interesting that you're putting a delay in to let the world load? Like, what happens if you don't have this? Like, is this just something that's like, oh, you better do this? That's weird.
On our world, we're going to increment that number by 1. On our overlap event, which is our sphere when we walk over our collectible, we're checking if the other actor is our character class. And if it is, we then get the game mode again, cast it to the correct type, and call the collectible collected, so it will remove 1 from our collectible count. I'm going to go ahead and close our collectible. Going back into our VP communication, let's see about creating our event dispatcher. We'll create an event dispatcher. We'll call this collectible count updated. Now we want this collectible count updated to be called whenever we register or collect an item. And if we drag this out, we're going to choose call. When this event is ran, anything that is registered or listening to the collectible count updated dispatcher will be notified. We'll go ahead and hook this up. We'll duplicate this node with Control D. We'll hook it up to the top one.
Nice.
Now we have our 2 events set up. Now we actually need to do something when the call collectible count is updated. Let's go ahead and quickly set up a test. Drag out our collectible count updated event dispatcher, and we'll do an event. Whenever this is called, we're going to do something. Later we'll use this to check and see if we've collected all of the collectibles, but for now we'll simply print out the current value. We'll use a print string. We'll grab our collectibles left and get it and plug it in, and let's go ahead and test. We'll compile and save, go back to our starting map, move to one of these locations, and then hit play. Well, nothing showed up in our print string. We can even go and collect an item, and nothing's happening. We implemented the event, but why is nothing happening? The reason for that is we haven't actually bound or added ourselves to the list for this event.
Oh, right.
This is the event we have set up that we want to call whenever collectible count updated is triggered.
No observers.
But we're not actually listening to that. We haven't assigned ourselves to it. We haven't bound it. If we drag out collectible count updated and we look at binding or assigning, binding is what we call and we hook up an event in order to subscribe to the list. If we drag off again and we do assign, you'll notice it basically handles that for us. It gives us our bind, and we do assign. You'll notice it basically handles that for us. It gives us our binding and creates our custom event. Let's go ahead and delete this. We need to go ahead and make sure that we set up our binding. Even though this event dispatcher exists in this blueprint, it's still more of like a signature or like your interface. You still need to do something with it. We'll hook up our bind event to our begin play. Do something with it.
Oh. This here.
We'll hook up our bind event to our begin play. With this set up, when the blueprint starts, we will bind an event, which is this custom event here we've created, to the collectible count updated event dispatcher. So whenever something calls it, these 2 items for example, then this will happen. Let's go ahead and compile and save, and then test again. And after 1 second, it should show 1, 2, and 3 because our collectibles are now registering properly. And when we collect them, it's going to go ahead and go down. Now, this is good and all, but we still need to be able to actually hook in something else. So let's go to our user interface, go back to our map. In the UMG folder, I have UMG_player UI. Now, if we go ahead and take a look at this, it's fairly simple. We have some text showing us the collectibles left, and inside of our graph,
so we're dabbling with UI.
We want to update this variable whenever it's left. And inside of our graph, we have nothing. It's fairly simple. We have some text showing us the collectibles left. And inside of our
graph,
we have nothing. We want to update this variable whenever we have something collected in the game mode. So we will register and listen in. Grab our variable and get it. We're going to go ahead and call a set text. We're going to set text. Now we want this text to be set whenever a collectible is updated, and that's in our game mode. So let's go ahead and get the game mode. We'll go ahead and cast that to our correct one. And then we want whenever the collectible update is called to trigger the set text. We can call that event directly, but that's not what we want. We want to listen in whenever it is triggered. So this is where our assign or our bind is set up. So let's go ahead and assign. You'll see it's gone ahead and created our bind event and our event that's going to be called. We'll go ahead and move this over and hook this up to our set text. Clean this up a little bit. Go back to the beginning and type in construct and our event that's going to be called. We'll go ahead and move this over and hook this up to our set text. Clean this up a little bit. Going to be called. We'll go ahead and move this over and hook this up to our set text. Clean this up a little bit. Go back to the beginning and type in construct. And whenever this widget is now created, it's going to go ahead and bind itself to the collectible count updated, and then we'll update the text. Now, where are we going to get that information from? This updated, and then we'll update the text. Now, where are we going to get that information from? This is an issue. We have no way of updating this variable. That variable is inside of our game mode. Well, it's not that hard. We'll go back to our event dispatcher, and we'll go ahead and add in a new variable.
Event dispatcher, GM2, GM, communicators, event dispatcher.
At the top, under inputs, we can do a new parameter. We'll call this one the count. It's going to be an integer type. And we'll go ahead and compile and save so the signature is updated. And now whenever we use our collectible count updated, whenever we call it, so our two events here, we can go ahead and pass along the new value. We can.
Oh, wait, no. Image2. Oh, count, okay. Event updated,
And now whenever we use our collectible count updated, whenever we call it, so our two events here, we can go ahead and pass along
count.
The new value. We can hook it up from our decrement and increment or just drag in our variable. And now the count will be passed along. We'll go back to our user interface. Inside of our event from our binding, you can now see it's updated with the count. We can drag this into the input text and let it convert. Let's go ahead and compile and save. We're still not actually adding that user interface to our screen. I'm going to go ahead and put it in the game mode to make it simple. After we have bound to the screen, I'm going to go convert. Let's go ahead and compile and save. We're still not actually adding that user interface to our screen. I'm going to go ahead and put it in the game mode to make it simple. After we have bound to this event here, we're going to go ahead and create and display our user interface. So we'll drag off and do create widget. Make sure we set it to display our. We have bound.
Event begin play. Wow, why is yours? Okay. Collectible count update. Oh, they still got their string going. That's why, okay.
To this event here, we're going to go ahead and create and display our user interface. So we'll drag off and do create widget. Make sure we set it to our UMG player user interface. And then off the return value, add to viewport.
There you are. Add to viewport. To viewport, okay. God, so many things. Just like you have to know.
Let's go ahead and compile and
remember
save.
these little things.
And then let's go back into our map and hit play. So it's 0 for a short amount of time in the bottom left, and then goes up to 3 as our collectibles register.
Okay.
When we walk over collectible, it updates itself appropriately to 2, and then 1.
I don't know where our collectibles are. Yeah, we haven't fixed this part yet, so. Yep. Boop. Boop. Neat.
And then if we walk over the last one, we now have 0. Event dispatchers can be very helpful when you want to have items try and manage themselves, rather than having one place to handle it all. Imagine if you had one blueprint that handled all the code that needs to happen on every frame, rather than the way it is handled now, with the engine letting the individual objects handle their own tick event. Our next step is going to be implementing our final door. We're actually going to see how we'd implement it using all of our previous methods, and then you'll be introduced to one last way to find items and initiate communication. We've looked at different ways of communicating between blueprints, with the main concept being getting a reference or variable to what you want to talk to, and then talking to it correctly. Our final goal of this project is to open the last door when the coins are all collected, and we'll examine all the methods we've discussed so far and how they could be used to accomplish this. So this is our final area, and we're going to need to be able to get into our last room. Let's go ahead and grab our BP door. We'll create a child. We'll name this one Final.
Door. Great child.
And we'll replace the one that's in our wall. So now we have a door we can go through. We need to be able to open it. Inside of our blueprint communications, down here in our collectible count updated, we need to be able to check and see if all of our collectibles have been collected. So once our collectible count is 0. Now, this is the spot we probably want to have been collected. We'll count up.
Alright, sorry. Button distractions. Blame the button, it's all their fault.
We need to be able to check and see if all of our collectibles have been collected. So once we need to be able to open it inside of our wall. So now we have a door we can go through. We need to be able to open it. Inside of our blueprint communications, down here in our collectible count updated, we need to be able to check and see if all of our collectibles have been collected. So once our collectible count is 0. Now, this is the spot we probably want to do it, because whenever the collectible count's updated, we can simply check. We'll do an equal or less than, and we'll compare it against 0. And we'll do a branch, and if that is true, then we will call the final event. We'll open the final door. And what we will do is create a custom event called Open Final Event. We'll open the final door. And what we will do is create a custom event called Open Final Door.
It's very event driven. I don't dislike, but holy cow.
And this will be called whenever we want to open the final door. So if we're down to less than or equal to 0 coins left, we'll go ahead and open the final door. Okay, our code's good here. We could set in something in false if we wanted to, but this is what we care about. So how do we open the final door? Well, our first method would be using the level blueprint. If we go into our starting map, here's our door selected. First method would be using the level blueprint. If we go into our starting map, here's our door selected. We can go into level blueprint. Inside of our level blueprint, we know we can easily create references.
Okay, was the level blueprint? Oh, okay, I didn't have it open. Got it.
And we can call events on them. So we could do that, but then how do we tell our level blueprint to call this event? Unfortunately, you can't really get into our level blueprint, so level blueprint really isn't going to help us very much. Our next method would be in our same blueprint. So here's our game mode for our blueprint communication. How can we get a reference to that door? That door does not exist inside of this blueprint. It is a separate object. Okay, so we're not going to be able to do that. Well, then we can do the public variables, right? It is a separate object. We could create a variable. We could make it exposed.
Messy.
Go into our starting map. We could find our game mode, and you'll find an issue. The game mode isn't at design time.
Oh,
it's simply spawned in at runtime. Okay, so we're not going to be able to use a public variable. What about casting? Well, we're going to run into the same issue. Casting still needs a reference, and we haven't been able to give that reference yet. Okay, blueprint interface. Again, you still need a reference to call that blueprint interface on. That's not going to work. What about an event dispatcher? That could work. We could actually take this final door and have it register itself with our game mode as the final door. It can pass in that variable, and then we would have that variable in here for the final door. We do have one final method. We have get actors. We have a few different ways of calling get actors. This shouldn't be used very often. Get actors can be slow if there is a lot of actors or you do it very often. Doing it on a tick, for example, probably isn't smart. However, we could have used it to grab all of our collectibles in our level rather than registering them. And it would have been fine. It would have been a one-time thing. So let's go ahead and look at the get actors. And you can see we have a few different things come back. We can search for actors based on their class, tags, interfaces, even a component list. And the nice thing is there's both the get actor, so we'll return one item, or actors if we have multiple, maybe all of our collectibles. Let's look at the get actor of class. We'll hook this up. When we open the final door, this will get actor of class. We need to put in the class. Now, if you noticed in our map, I named this one door final. This is our class type. Go back into our there. We'll type in final. And there we go, BP door final. By naming that blueprint uniquely, I know we only have one in our level. This will give us that item. Since we have that final door, you'll notice the return value is final door. This is important to note. Because blueprints are dynamic, if we have none, it's going to return back a generic actor object. But if we have the specific class, it's going to return back that specific class. However, if you hook up your code before you choose the class, it's not going to change the return value. So try to set up your class first so your return value matches. We can go ahead and call open door. And at this point, well, our code's honestly done. We can compile and go back to our map and check. We have 3 collectibles. We can wander around our level. We can collect the collectibles. You'll notice our door is closed. Collecting the last one opens the door. We go in. And we win when we collect the final item. Going back to the blueprint, we also have the other get actors. So if we get actors of class,
I don't even know where the third one is.
this will be the same as get actor, except return an array of multiple items. Also the tag version, we have class with tag, and we have just get all actors with tag.
Am I
These
being blind?
are actor tags on the actor itself. So inside of here, this is a game mode. It doesn't have any tags. If we go into our blueprint, for example, for our door,
yes, that worked. Very cool.
B, door is closed. Collecting the last one opens the door. We go in, and we win when we collect the final item. Going back to the blueprint, we also have the other get actors. So if we get actors of class, this will be the same as get actor, except return an array of multiple items. Also the tag version, we have class with tag, and we have just get all actors with tag. These are actor tags on the actor itself. So inside of here, this is a game mode. It doesn't have any tags. If we go into our blueprint, for example, for our door, and we search for tag, because this is an actor, under the actor's tags, we have a tags array, and we can organize things. You may want to, for example, for our door, it doesn't have any tags, actor itself. So inside of here, this is a game mode. It doesn't have any tags. If we go into our blueprint, for example, for our door, and we search for tag, because this is an actor, under the actor's tags, we have a tags array, and we can organize things. You may want to make your collectibles have a tag of collectible, or your doors have a tag of door. And using the get actor commands, you can filter them out based on the tag as well, and grab all of your doors or coins or collectibles. It's another way to identify things. Keep in mind, this is an actor tag. It'll only be on actors. Your components themselves have component tags. Those are different than actor tags. Congratulations. Good work. Now that we've completed our project and we've looked at the various methods of communication between blueprints, you should be able to apply this information working on your own projects. There are multiple ways that we have covered, and generally, there's not one specific correct way. You should go through like we did in this last section and examine your options, determine the best one for what you need to get done, and see about implementing that method. Blueprint communication is a fundamental part of working with Unreal Engine and blueprints. While you could try and contain all of your code within the level blueprint, or even a single actor blueprint, you might run into issues managing all of that information. By breaking down what you want to do, you should be able to find a way using the methods we covered in this course to create an efficient design, such as using the level blueprint or communicating between components in the same blueprint. We exposed variables inside of a blueprint to make them public, so that way we could set them up at design time, and we used casting to confirm the item that we want to communicate with. We created a blueprint interface to allow us to communicate generically and message other objects, so that way if it doesn't support it, it just simply fails silently, as well as event dispatchers to allow us to create a list that things can listen in on. We also looked at the get actor nodes as a simple way to get actors of a certain type so we can start that communication process. I really hope you enjoyed this course and took away some useful information on how to communicate between blueprints. Some of these concepts are more difficult than the others, but after this course, you should have the basic idea of how we can communicate between objects in our projects. If you feel you are stuck, try all the methods to see which might work well for your goal. Keep in mind, with all things related to programming, there's usually more than one way to accomplish your goal, which does not mean any way is more correct than another.
Alright, so let's see if we can figure out our bug. Because we have a bug. We have a bug. This works. This works. And this works. But this does not work. And then we figure out why. Trigger. So let's see. BP trigger. That's weird. Where'd the window go? I'd very much like to have a window. Thank you very much. What? BB trigger. Gotcha. Okay. I need to disable that feature. Do not want. Alright. Let's go back to try and figure out what was going on here. Okay. BP. Auto breakpoint. I'm gonna guess has key is false. Has key is false. Okay, why is has key false? Where were we setting that? BP. Communication character has key, so boolean. Has key item. I don't remember what actually. Has item. Yeah. Has item. Key equals item. Where's the item? Where was this getting called? Oh. That's an interesting point. Since they're not using like IDE type thing, how do I find out what's calling this? Find references. By name. Okay. That's not useful. All. BP. Trigger pickup. Trigger pickup. BP trigger pickup. Item. Key. And so it's that's item. Item key. But then BP character. BP communications. Character. That's item. Where's item coming from? Item was key. This key. Item key. So items coming from here. Key is that. This is from here. No, wait. So trigger pickup. Event when shown, interacting with. Event interacted with. Has key. B. Door trigger. B trigger. That's how character. It's BP. Show target. Has key. Boolean. Else nine scope. What does that mean? I don't know what that means. What do you mean has keys, not in scope? Let's keep boolean. That one works. Why is save variable not shown? What? Variable not in scope. Okay, so that's the same material. Target. I don't know what actually is setting the key. I mean, I could just do this and go bam, but that kind of defeats the purpose. Has key, has item. Tries to access blueprint show. The blueprint to always be loaded. Okay, why am I... Condition is true, otherwise false. How is it not giving me... Read the volume. Bark. Yes. Oh, there it goes. Now it's showing me. Yeah, value true. Okay, let me open the door. Voila. Okay, but push this. Do that. Go blat. Go blat. Go blat. Go blat. Doesn't matter. Oh, streamy bark. All the barks. Okay, so I still don't understand. What did I do wrong? I must have missed something to actually get the has key. So, find references. Name. No. Find references. Oh. Let them out. Get has key. Nothing sets this. DB Communications just has key. Where did they set the key? Okay, I must have missed something.
Now how, so we'll just type in door to open again. This time we can just set this to a generic door. So we'll do BP underscore door. We'll go ahead and compile and save.
Okay, so right now you're at BP trigger. Door to open, I've got that. Has key.
We'll expose it. Let's go back to our starting map trigger. Now you have compose and connect to door. We can go. We want a BP door, child, and everything else that knows.
Oh. Okay, hold on. Maybe I'm just. Maybe I'm not actually getting the. Nope. Try again. Maybe we didn't write that in this game. Maybe it was already done. No, because it's not referenced. Do that. I don't care about this anymore. Yeah, wait, where did you get the key? No. I'm so confused.
About it has been updated. Now we need a door to open. If we click on our list, we can see we have 2 doors. So we'll put our door in. We're just going to replay. Which one's the 30? You can figure itself that's on the floor. Select it. And the trigger and the door are connected together using our public variables. Now, how do we do our key check? Inside of our blueprint trigger, inside of here, we're checking if our character has the key, and if so, we're doing something. Grab our door to open, get it. We're going to do open door. We'll hook this up to our true, and then we'll test. We'll hit compile, save, go back to our map. Did see that before. Let a few balls drop through. Remember, the balls are checked. And the door, well, the door didn't open. The door didn't open because inside of our trigger, we are checking to see if our player has key. Inside of our player, we have the variable, but it's set to false. Let's set it to true. Compile and save.
Oh, they just straight up set it as true.
We'll go ahead and hit play to test again. We'll look at the door, watch the balls land on it. They shouldn't work. Our player should be able to go over it, go back.
So they never did, they just...
By using the casting, we're able to treat one item, in this case an actor, as another.
Got it. So they never set up a key.
Character, and then work with it. Our
they just set it to true.
Character has this variable. The items above it do not. It's unique to this one and any of its children. We've kind of seen that before with the events like the opening door and overriding the parent. So this is where casting will come into play. Anytime something is returned as an object type that is something that you don't want, and you need to work on it more specifically, that is when you'll use casting. It's also useful if you simply want to do a quick check on if something is something. You can cast, and if it is not, it will fail, and you can do something appropriately. However, continually casting, let's say we want to check and see if the character or the round ball or maybe another character, or even if we want the AI to open it, are all available and allowed to open, we'd have to cast. If it fails, check again. If it fails, check again. And that can lead to a lot of bloated code. And that's kind of where our blueprint interfaces come in.
Oh. Why can't I go back? Oh, right. That's the lever thing. Make the balls do damage. There isn't even a health or damage thing in this game. Doesn't exist. Yeah. Okay. So we do have everything working as much as the tutorial is intended to be. Let me go back into Zoom. These balls are probably just dang it, sorry. So move the box up thing, go through the door that just works, the lever that just works. You gotta go Push ourselves through here. Pop that. Grab. This is all. Huzzah. Okay. It's all done. Lighting. Shadows. Thanks everyone for hanging out. As always, be well, be safe, be yourself, be kind, be all the good things, and have a great rest of your day.